Everyone, Mr. Neighbor here, and today we're going to talk about Chapter 11, Motion. We're going to start with 11.1, which is measuring motion. Specifically, we're going to be talking about displacement and velocity. Before we get into those topics, we need to talk about the different quantities we're going to use within physical science and physics. The first type of quantity is a scalar quantity, and a scalar quantity is a quantity that only has a magnitude. It doesn't have any direction associated with it. So, how fast are you going? You could say 55 miles per hour. What is your mass? 75 kilograms. What's the temperature? 130 degrees Fahrenheit. How much time is left in class? 45 minutes. It's only a number. That number should have a label, but it is only a number, no direction specified. Vector quantities, they have a magnitude and a direction associated with them. So you might be going 35 miles per hour east, or you might have a force of 75 newtons downward. It always has a direction associated with it. Some things that are vector quantities are velocity, displacement, and acceleration. So we'll get into those next. Okay, so here are some definitions for you. We're going to be talking for quite a bit of time about linear motion. So linear motion refers to motion in a line. So that motion can be described using a number of different quantities. It could be a number line. You might be able to do it in a graph with time as an axis. Sometimes we'll just have a bunch of dots to represent linear motions over time. There's a lot of different representations that we'll use for that. The word constant we take to mean a quantity that is not changing during a given time. It's always the same speed. It's always at the same position. It's constant, not changing. If you hear the word instantaneous, we're talking about that quantity at a single moment in time. So that quantity is probably changing, but we want to know at this instant, at time of 2 seconds, what is that quantity? So it is changing. Time is referring to how long an object is in motion for. We use seconds a lot of times because that's our base unit for time. If it's in minutes and things like that, that's fine. But when calculations are concerned and there's time in a formula, that time quantity needs to be in seconds. And then distance is simply how far something travels along its path. That could be kilometers, meters, centimeters, feet, or any other unit. Some more definitions for us. We just talked about distance, but I want to compare distance with another term, displacement. So distance is how long or how far you've been traveling. In other words, how many steps you took. How much would your phone register that you took for steps, or your Fitbit, or whatever it is. Displacement, on the other hand, is how far you are from your original starting point. So the difference is, if you look at this map, your distance is how many steps it takes to get to the X. Your displacement is the direct line from where you started to the X, going through all of this junk right here. So this in green would be the displacement. All right, it's a direct path. If you didn't move, or if you did a very roundabout path to get to that X, and maybe you didn't find the X and you ended back at your starting spot, your displacement would be 0, but your distance would be quite a bit. So distance, displacement, almost the same, but not quite. Speed and velocity are like that as well, where speed is measuring how fast your distance is changing, how fast you're going. Velocity measures how fast your displacement is changing. So notice how fast your distance is changing versus how fast your displacement is changing. And the displacement has a direction. So this is a vector quantity. That means velocity also is a vector quantity. Distance and speed, they are scalar quantities. They don't have any direction associated with them. And then lastly, acceleration, that is a measure of how fast your velocity is changing. So that is also a vector quantity. It also has a direction. All right, so displacement. This is our formal definition for displacement. It's a measure of how far you have displaced or changed your position from your starting point. So because it's a vector, you need a direction associated with it. For example, what is your displacement coming to this class? It's 157 meters east. How high can you jump? 1.3 meters up. That's how high you can jump. Maybe you can say you jump a different distance horizontally, but we're specifying up in this case. So we don't know the horizontal jumping distance. So when we talk about displacement, we associate displacement with position, which is the variable x. So if you see something with distance, you're probably going to see a d for distance, but with displacement, you're going to see an x. So keep that in mind. This triangle is the Greek letter capital delta, and capital delta refers to change. So what this symbol means, the change in the position is equal to, sorry about that, the displacement means the change in the position is equal to the final position minus the initial position, okay? The final position where you ended minus where you started. So that's a subscript F and a subscript I to symbolize final and initial. You'll see that a lot in physics. Displacement can be horizontal and it can be vertical, as I mentioned in the last slide with the jumping. So when we refer to things that go horizontally, we're going to talk about the x-axis. And when we refer to things going vertically, we're going to talk about the y-axis. So that formula that we had, delta x, as the change in position or displacement, it might be delta y as well, because then we're talking about a vertical change in position. But positive x, we usually refer to that as the rightward direction, and negative x, leftward. Positive y is upward direction, and negative y as the downward direction. So let's look at some practice problems. All right, in our first example, a high school track runner runs 400 meters around a track and stops at the starting line. Calculate the distance and the displacement. So distance is how many steps you took. So that's 400 meters. Displacement is how far you are from your initial starting point. Well, if he starts at the finish line, or he finishes at the start line, then he isn't any further from where he started. So the displacement is 0 meters. He traveled. No displacement. All right, example 2, a farmer drives a tractor to a cornfield 3.5 miles away. Then he drives back to a pasture 1 mile from home. Assume that all 3 points are located on a straight road. Calculate the distance and displacement in each of the following scenarios. So let's look at what's happening. We're starting here with our tractor. We're driving 3.5 miles. And then after that, we're going back right here. And that's 2.5 miles back because we know it's 1 mile from home. So what's the distance he traveled? Well, he traveled this distance and then back to right here, which would be 3.5 plus 2.5, which would give us out 6 miles. Oh, and actually, let's do appropriate sig figs here. I'm adding 2 numbers, and they're both going to the 10th spot, so 6.0. And then the displacement, how far am I from the starting point? Well, I started here, I finished here, so this is the displacement, which is 1. So 1.0 with correct sig figs miles. Try to get one last example in here. We have a graph of position, and we want to know the distance that this car traveled. So it starts at 0.5 and it goes to like 3.75. So the distance that is the final position minus the initial. And that will give us out 3.75 minus 0.5, which is about 3.25. So that would be the distance traveled, and it's actually also going to be the displacement, because that's how far you are from the initial starting point.